This is just more practice. I think that you've already probably done these. So I'm just going to put some answers down and talk as I do it. And then if you have questions, we'll go back and look at them. For find the oxidation number for sulfur. Here we have sulfur dioxide. It's on the left, so I expect it'll be positive. The only time you can have something on the left that isn't positive is if hydrogen is involved. Hydrogen we would typically put on the left, but there's some times when we don't put it on the left. And the reason is if you put it on the left, it looks like an acid. But the oxidation number for hydrogen in compounds is +1 in covalent compounds. Now, could it be in an ionic compound? Sure, and then we would call it hydride. But that's not going to happen in our class. It happens in life, but this is the first chemistry class, so that typically is not going to happen. So hydrogen, the element, has an oxidation state of 0, but hydrogen in covalent compounds is +1. Typically, unless hydrogen is involved, the one on the left is going to be the positive one, either because it truly is the positive one, or because we're pretending it's a covalent compound and we're saying, you got to be the cation. So we look at the thing on the right and say, well, oxygen would be like oxide. And there's 2 of them. Sulfur plus 2 oxides adds up to the overall charge, which, because it's a compound, is 0. And so in this case, sulfur is +4. For something that is ionic, B, I'm going to separate the cation and the anion. And then if I'm looking for sulfur and it's in the anion, consider that by itself. So right now I'm considering sulfite. No kidding. Why do I do that? Because I'm less likely to make a mistake. So when I separate them to cations and anions, I have to let the charge show. Sulfur plus 3 oxygens adds up to the new charge, which is -2. Each oxygen is an oxide. And so sulfur -6 equals -2. Add 6 to both sides. Sulfur and sulfite is +4. Okay, here we have an element. And an element, the oxidation state is 0. Here I have a covalent compound, but I can kind of separate it into 2 hydrogens and a sulfide. Or I could say 2 + 1's, 2 hydrogens, and a sulfur adds up to the overall charge, which is 0. Sulfur plus 2 equals 0. Sulfur must be -2. Okay, so here I have something that's ionic. It starts with sodium or potassium. So I'm going to pull the potassiums off. And so 2 + 1's accounts for 2 potassium ions. And now I have S2O3 2-. When I start pulling things apart so that I can look at them, I remember that I keep all the nonmetals clumped together. So I can pull off the metals from the nonmetals, but I don't pull the nonmetals apart until I'm ready to start dissecting this. Now I say 2 sulfurs plus 3 oxygens in a compound, each one's -2, adds up to the new overall charge, which is -2. 2 sulfurs -6 equals -2. Add 6 to both sides. 2 sulfurs equals +4, so each sulfur must be +2. Okay, so here I have 4 sulfurs plus 6 oxygens adds up to -2. 4 sulfurs -12 equals -2. Add 2 to both sides, add 12 to both sides. Divide by 4. So in this compound, each atom of sulfur has an oxidation state of 2.5. How is that possible? Because It's the idea of electrons. So we can have the idea of half of an electron's worth of charge. Here we have lead 4 sulfide. And sulfide on the periodic table would gain 2 electrons to be like argon. So the oxidation state in this ionic compound is -2. Each sulfur in that compound has a -2 oxidation state. Here I have an acid, and I can remember where the acid came from. This is sulfuric acid. It came from sulfate. Gained 2 hydrogens to be neutral to be an acid. So I'm just going to focus on sulfate. 1 sulfur, 4 oxygens, adds up to the overall charge. So for B, I have an ionic compound. Cation is ammonium ion, anion is chloride. So I'm going to pull them apart and just look at ammonium and the nitrogen in it. So the hydrogens are going to be +1 or 0 in our class. So nitrogen +4 equals +1. Subtract 4 from both sides, it's -3. How can it be negative and on the left? Because it has hydrogen. And we can't put hydrogen on the left unless we're really talking about acids. C, this is an ionic compound, so I want to break it apart. 1 iron 3 and 3 nitrates combined to make the formula unit. So let me just look at 1 nitrate at a time. So nitrogen -4 equals -1. Add 4 to both sides, it's +3. Okay, we just figured nitrate in the last problem. Questions? So this is, the reason I'm doing this again is because this is something you're going to turn in tomorrow for points. I want to make sure that it's clear how you're supposed to fill in the blanks. So for each of the chemical reactions, indicate the oxidation state of each element and each reactant and product. So I need to go through and assign some oxidation numbers. Sodium is an element, so it's 0. Hydrogen in a compound is +1. Oxygen in a compound is -2. Here we have an ionic compound, but still, sodium is a group 1 metal. Sodium ion has a +1 charge, and the charge equals the oxidation state. Oxygen in a compound is -2, and hydrogen is +1. And here we have hydrogen as an element. So sodium went from 0 to +1, and if you go up in oxidation number, you're oxidized. The reactant that is oxidized was sodium, and the element was sodium. And that seems redundant, but go ahead and say those things. This state went from 0 to +1. And if you go up in charge, you're oxidized. The reactant that was reduced, well, hydrogen went from +1 in a compound to 0. And so I would say the reactant was water, but the element that actually changed was hydrogen and water. Okay, same process here for B. I'm going to assign oxidation states. Hydrogen is +1. There's 4 of them, and it has to add to 0, so carbon was -4. Oxygen's an element. Oxygen in compounds is -2. If there's 2 of them and that added to 0, this must be +4. And then hydrogen compounds is +1. So carbon went from -4 to +4. And then oxygen went from 0 to -2, either here or there. So it was reduced. Okay, for this last one, same process. Hydrogen is +1, oxygen is -2, and I'm ignoring the coefficient. I'm just looking at hydrogen plus manganese plus 4 oxygens adds to 0. +1, 4 times -2 adds to 0. So manganese -7, -8 and +1 is -7, adds to 0. It must be +7. This compound is ionic. There's 2 nitrates. Nitrates are -1, so this must be manganese 2 nitrate. And in nitrate, the nitrogen's +5 and the oxygens are -2. We figured that out above. Chlorine's an element, hydrogen and compounds, oxygen and compounds. So here, I see that the manganese and permanganate went from +7 to +2. It got lower. If you go negative on the, or to the left on the number line, that's reduction. So in permanganate, the manganese went from +7 to +2. It was reduced. And the thing that was oxidized was the chlorine. It went from -1 to 0. Okay, that's all I have.